Hello students, so good evening all. Right. Today we are going to discuss differentiation graphs. Some past paper questions actually, only differentiation graphs, only the first application, not the second application. So 2024, 5 and the most recent paper, and also 2021 and 2013, right. So those ones we are going to discuss on. Right. Let's move to the paper, right. Okay. I hope you have watched the recordings that I have sent to cover the main parts. And with my theory students, actually, we have already discussed the things, right? Okay. And so here, this is a given function. Let fx equals to 4x plus 1 over x into x minus 2. For x is not equal to 0, 2. So why it is not equal to 0 and 2? Because the function will be undefined because of these two values, because then the denominator will become 0 for these two x values. Clear? Right. You have to show that f dash x, the derivative of fx, right, is given by f dash x, which is equal to this. Right. You have to first of all find f dash x, right? So we will do that part first. Right. Now the given function is 4x plus 1 over x into x minus 2. Right. So when it comes to division, and it is in the u over v format, right? When we differentiate it, yes, what you have to do? Denominator squared, right? Denominator squared. So denominator squared means x squared, x minus 2 squared. Then denominator into differentiate the numerator. Okay, you start from the denominator. Denominator into differentiate the numerator. So what is the denominator? X into x minus 2. And you all differentiate this. Once you differentiate 4x plus 1, once you differentiate 4x, it is 4. Once you differentiate 1, it is 0. So the answer is 4. Clear? Then minus. Now numerator into differentiate the denominator. Denominator into differentiate the numerator. Numerator into differentiate the denominator. So that is the way to do, right? See, 4x plus 1 into, you have to differentiate this. Clear? Now what is this? Once you expand it, what is it? This is x squared minus 2x. Ne? X squared minus 2x. Right? So when you differentiate this one, differentiate x squared, 2x, differentiate minus 2x minus 2. So you are getting 2x minus 2. 2x minus 2 there. Clear? Right. Then, okay, so we have to further simplify this one to get the answer. Right? You can see 4 into x, 4x into x, 4x squared, 4x minus 2 minus 8x, right? Then minus, we have to multiply these things. There are getting 8x squared, 4x into minus 2 minus 8x, 2x into 1 plus 2x, so minus 6x altogether. Then 1 into minus 2, that is minus 2. Clear? Denominator we get as x squared, x minus 2 whole thing squared. Clear? Right. Then, yes, so the first sum actually I will do it for you, right? Then for the next ones I will just give a little time for you to try, right? So first question I will do, right? Because there are some new students also. So I will do the first question for you, right? See, 4x squared, now simplify, 4x squared minus 8x squared, put there minus 4x squared, right? Minus 8x plus 6x minus 2x, minus into minus 2 plus 2. So you will get like this, x squared, x minus 2 whole thing. You can see in each and every term you have 2. We can take 2 out. So now you target your answer. You can observe your answer here. You can observe your answer with it. Here see, f dash x is equal to minus 2 into 2x minus 1 x plus 1. Clear? So once you expand 2x minus 1, x plus 1 is the answer. When you take minus 2 out, and then see 2x into x, 2x squared, plus 2x minus x plus 6, minus 1 into plus 1, minus 1. So isn't it the same thing when you take minus 2 out from this one? What remains here? Plus 2x squared, when you take minus 2, plus 6 will remain, and here minus 1 will remain. Clear? When you take minus 2 out, I mean this term will be minus 2 into minus 1 plus 2. When the only, right? Therefore, you have to write minus 1 inside the bracket. So this is it. Clear? Right. Over x squared, x minus 2. I think you have already got the answer. So once you factorize it, we will get 2x minus 1, x plus 1 over x squared into x minus 2 whole thing. So that is the way to differentiate this. Okay, the first task that you have to do is this. Raise hands also can understand the thing. Getting f dash x. Right, differentiate once. Okay. Right, you can note down this thing. You can do the question with me. Yes. You can do the first question with me. So note down this. Okay. Right. Now, I think the first line is enough, and then you can simplify it along. Right. So once you simplify it, you get this. Clear? Right. Now, we have to move to the next part of the question. Right. Let's see what we have to do. Okay, Bhutesh, see? Hence, find the intervals on which fx is increasing and the intervals on which fx is decreasing. Right? That means now you have to find the intervals on which fx is increasing and decreasing. Clear? That is the thing. Right. So, finding increasing and decreasing ranges, finding increasing and decreasing intervals. Right. So, now we have fx and we have f dash x. Right. So, before finding increasing, decreasing things, you have to find the vertical asymptote and you have to find the turning points. I mean, you have to find the stationary points. Clear? And then we have to identify what are the increasing and decreasing ranges. That is what you have to do. Now, look at this, all of you. Find in the vertical asymptote, right? So, we are drawing the graph for this function, right? We have to draw the graph for this function. Right, vertical asymptote. Right, what do you mean by the vertical asymptote? Right, this is the point at which the function is undefined and tends to infinity. Clear? So, the function, this is a fraction. The given function is a fraction. This fraction will be undefined when the denominator is equal to 0. So, for which x values, this denominator will become 0. Right, this time it is actually for x equals to 0, right, and for x equals to plus 2. See, when x equals to 0 and when x equals to plus 2, denominator will become 0. Clear? So that is the vertical asymptote. That is we have two vertical asymptotes here. One is x equals to 0 and the other one is x equals to 2. Right? Okay. Next one. We have to find the stationary points. Clear? What do you mean by stationary points? What are stationary points? Minimums, maximums, and sometimes the point of inflection also we can have what we call point of inflections also sometimes can be stationary points. Okay, right. So how to identify these turning points? Right. So we have to write like this. See, at stationary points, right, f dash x is equal to 0. At stationary points, f dash x equals to 0. So the f dash x means this. Clear? Now this is equals to 0. This is equals to 0 when the numerator equals to 0. F dash x is a fraction. A fraction is equal to 0 when its numerator is equal to 0. So when we get the numerator 0, that is when, right, x equals to plus half and when x equals to minus 1. So these are the stationary points. Clear? Now we have two stationary points and two vertical asymptotes. Clear? X equals to half and x equals to minus 1. I hope you can understand. F dash x is a fraction. So at stationary points, f dash x equals to 0. What do you mean by f dash x? Gradient. F dash x gradient of the tension. At stationary points, at these kind of points always, I told you last week, the gradient is 0, right? F dash x is 0. Clear? That's right. Right. Okay, Lamai. So, it is right. Now, what is the next step? Now, we have to move to this increasing, decreasing right now. Right? Finding increasing, decreasing range. So, this is what you have to do. Now, you got some vertical asymptotes and you got the stationary points as this. Right? What you have to do is very simple. You just draw a number line, like something like a number line, okay? And then mark these four values in order. Clear? Right, let's do like that. So, mark them in order. We have four values now. We have four values, okay? Right. What comes first? Minus 1. Then 0. Then half. And then 2. Like that, you have to mark them in order. Clear? Then, you just draw a line, draw lines from these points to build up this chart. We chart lines right? And then you write down the ranges. Then write down the intervals, right? Okay. What is the interval here? Minus infinity to minus 1. Here we have the x values from minus infinity to minus 1. This case, minus 1 to 0, right? Here, 0 to half. Here, half to 2. And here we have 2 to infinity. Clear? Right. Now we are going to observe these increasing, decreasing ranges. Yes, we have to observe the sign of f dash x. I told you f dash x means what? Gradient. We are going to observe the sign of the gradient. Why? Yes. Now let's say the curve is like this. Right? So here, gradients lie this way. Gradients of the tangents lie this way. In this case, gradients of the tangents lie this way. Right? Gradient of the tangent lie this way. Clear? So you know when the straight lines are like this, that means when the straight lines forms an acute angle with the positive x-axis, gradient is positive, right? I thought if dash x in gradient can, f dash x is positive. Clear? So the function is increasing, see? The y values are increasing. Can you understand? So at that time, f dash x is positive. Here the function is decreasing. How about the gradient? Gradient of these kind of straight lines, right? We know they are negative. Negative gradients. I thought f dash x gradient can f dash x negative. Here gradient is 0. F dash x. This is a turning point. So that's what we considered here at stationary point f dash x equals to 0. Can you understand? So there, now we are going to identify increasing and decreasing ranges now. So we have to discuss about the sign of what? Sign of f dash x. Clear? We have to talk about the sign of f dash x. Right. Listen me all of you. Here you have to write sign of f dash x. Right? For each and every interval, for the x values in each and every interval, you have to observe the sign of f dash x. F dash x sign එක බලන්න ඕනේ මේ හැම interval එකකම ඉන්න x values වලට. Clear? Right. f dash x නේ මේ ඉන්නේ. හරිද? ඔයා මෙයාව just write down it here like this. For -2, draw a bracket because -2 can, I mean the -1, they are -2, no? So they can change the sign of f dash x definitely. Because whatever the values you get from these brackets, that is multiplied by this minus at last. Clear? That's right. Then for this 2x minus 1, I will draw a bracket. And for this x plus 1, I will draw a bracket. How about the denominator? Denominator is always positive. Why? Both terms are squared terms. Clear? So whatever the values we substitute, always the output will be positive. So I will just write positive here. And for this bracket, I will put a minus. That represents -2 thing. Clear? So එතන තියෙන්නේ -2 ගේ minus එක. මේ දෙන්නගේ signs ගැන අපිට හිතන්න වෙනවා. මෙයා always positive නේ. නිසා teacher ඒක positive කියලාම ලියාගත්තා. Denominator එකට දෙන්නේ no need to draw plus into plus is plus into plus means plus, no? Right? Otherwise we can write it's okay, right? For x squared positive. For x minus 2 squared also, it will be always positive. That's why. Right. So for all the cases, you just draw like this. Because we have to think about the sign then, right? ඊළඟට sign එක ගැන බලන්න ඕනනේ. ඒ නිසා you just draw this for all the, I mean the format of f dash x in all these things. Right? හරි. ඒතර මෙයා හැම වෙලේම minus, here plus, minus, plus, minus, plus, minus, plus. Right. Now you just substitute one particular value in this interval here and just check what comes inside this. I mean what is the sign of this bracket and this bracket. Clear? මෙයාගේ signs අපි check කරන්න. මෙතන එක value එකක් substitute කරලා බලන්න අතට. හරිද? Because if you have written these things correctly, මේ -1 or 0 or half or 2, if you have written them correctly, then definitely you will get correct answers there, right? You can substitute කරන්න කියන බය වෙන්නේ නැහැ. Okay. See, a value which is less than -1, -2. So substitute -2 and see. 2 into -2 -1. 2 into -2 -4 -1 negative answer. Clear? -2 plus 1 negative answer. -2 plus 1 -1 negative answer. From -1 to 0. From -1 to 0 value place. Minus half is there. Minus half. Substitute minus half. 2 into minus half -1 -1 -1 negative answer. Minus half plus 1 positive answer. Clear? Like that you have to check the sign. මේගොල්ලෝ මන් දාගත්තා ඒගොල්ලෝ ආයෙත් හිත ඉන්න දෙයක් නැහැ. ඒගොල්ලෝ කොහොමත් positive වෙනවා කොහොමත් negative වෙනවා. That's why. Okay, 0 to half value please. We have 1/4. Substitute 1/4. 0 to half we have 1/4. 2 into 1/4 1/2. 1/2 minus 1 negative answer. Clear? 1/4. Sorry, 1/2 minus 1 negative answer. Here also we have plus 1/4 plus 1 positive. Clear? Now tell me a value which is greater than half, less than 2 please. We have 1, substitute 1. 2 into 1, 2, 2 minus 1 positive. 1 plus 1 positive. For these ones also definitely you will get both positive, right? Let's say substitute 5, 10 minus 1 positive, 10 plus 1, 5 plus 1 positive. Is it clear? Now you just think about the overall sign. Right? Now you think about the overall sign. Look at this. Minus into minus plus, plus into minus minus. Plus denominator again. This is sign negative. Here minus into minus plus, plus into plus plus. Over plus means plus. Minus into minus plus. So here plus. Here minus into plus minus. The answer is minus. Minus into plus minus. These are the overall answers that we get. Is it clear? Right. Now what you have to do. Then මොනවද අපේ තියෙන special points දෙක? Stationary points මොනවද දැන්? Yes. Half and minus 1. Half and minus 1 are the stationary points. Minus 1 maybe. This is the stationary point and this half is the stationary point. මේ බලන්න පුතේ. Here f dash x sign is negative. Right? F dash x sign is negative. What do you mean by that? Sign of f dash x is negative. That means to which, I mean, gradient ne? Gradient is negative. F dash x කියන්නේ gradient එක. Gradient එක negative නෙමෙයි. Here gradient is positive. If the gradient is negative, what kind of tangents you will get? Negative gradients in straight lines? This way. Tangents are this way. Clear? Positive gradient, negative gradient, negative gradient. So these are the types you get. Is it clear? Right. Then can you observe here the function is decreasing, right? And here the function is increasing. So decreasing, increasing, it forms what kind of a point here? A minimum point. Okay, so here we have a local minimum. We say minus 1 is the minimum point. Clear? Minus 1 is a minimum. At x equals minus 1, you can find a minimum point. How about this thing? Main stationary point increasing, decreasing. Right? Increasing, decreasing. So at half, you will have what kind of one? A maximum point, local maximum. We say half at x equals half, we can find the local maximum. Clear? Right. Then you have to write the increase. You have to find. They ask you to find the increasing, decreasing ranges. So you have to write in words. Here it is decreasing, increasing, increasing, decreasing, decreasing. Likewise, you have to write in words. Okay, you can continue writing. Rest of those who can understand the sum up to now. Okay, right. You all start to write. Yeah, shall we continue? Right, I will just erase this thing and I will write the sign here because I want more space below this, that's why. So however, when we compare the signs, right, when we compare the signs, we got here minus, plus. When we consider the intervals, we got here plus, here minus, here minus. Clear? Okay. Now, when they have asked in the question to write increasing and find the increasing and decreasing ranges, definitely you have to write it in words. Now, here this is decreasing, increasing, increasing, decreasing, decreasing, right? So, you have to write in words. Decreasing, right? Increasing. If it is positive, if the sign of f dash x is positive, the function is increasing, right? For in this interval also it is increasing. This one decreasing. So to get, I mean, definitely you must, to get full marks, definitely you write these things, right? So this is decreasing. Write in words. Is it clear? Right. Now, as I told you, we identified that here it is decreasing, increasing means this stationary point. This stationary point is the minimum. So we can write here local minimum. Right? Local minimum at what? X equals to minus 1. Local minimum at x equals minus 1. Right? And here at this stationary point, increasing, decreasing. So there it forms a local maximum. Clear? X equals to plus half. At x equals to plus half. Now we can find the coordinates of this minimum point and the maximum point. Now in this graph we will get a minimum point and a maximum point both. How to find the coordinates of this minimum and the maximum point? Yes, how to find the coordinates. But then when we know the x value, we can find the y value using this function, right? For this function we sketch the graph. This is the main one. මෙයාගේ තමයි අපි graph එක අඳින්න හදාන්නේ. ඉතින් මෙයාට substitute කරන්න x equals minus 1 substitute කරලා බලන්න y කියන්නේ කවුද කියලා. And also you substitute x equals half and then find what is y. There you can confirm what is the local minimum and the local maximum. Clear? Right. Let's do that part now. Right. When x equals to minus 1, y equals to what? When x equals to half, y equals to what? That's what we have to find. Okay. When x equals to minus 1, substitute minus 1 in this. 4 into minus 1, minus 4. Minus 4 plus 1, minus 3. Numerator you have minus 3. And then here minus 1, minus 1, minus 2, minus 3 into this minus 1 plus 3. So you will get the answer as minus 1. Clear? So x equals minus 1, y equals minus 1. So that is the local minimum. Local minimum coordinates we get as what? Minus 1 comma minus 1. Minus 1 comma minus 1. Is it clear? Right? You substitute what you got as x here. We found the stationary point and we know that it is a minimum point now. So you need to find the coordinates to mark it on the graph. Therefore, you just, once you find the x value, to find the y coordinate, you just substitute it here. That's all. Clear? Right. So let's substitute the same way this one. See, 4 into half 2, 2 plus 1, numerator is 3. And denominator half into half minus 2. This is the way we get. Half into half minus 2. So you can see half minus 2, that is minus 3 over 2. This is 3 times half into minus 3 over 2. Let's say 4. 1 minus 4 minus 3 over 2 you will get. Right, so this 3 get cancelled and denominator 4, so it is minus 4, right? Okay, so this is the local maximum and the coordinate we can write down like this: half comma minus 4, half comma minus 4. Is it clear? Right. Okay, so that is the way to find this local minimum and local maximum. Okay, complete up to this point. Okay, now let's move to the question, right? I will give more time after doing the whole stuff. Right, now let's move to the question. See, hence find the, so yeah, we did this part. Now sketch the graph of y equals fx indicating asymptotes. What do you mean by asymptotes here? It means both vertical and the horizontal asymptotes. Now we've already found the vertical asymptote, so we have to find the horizontal asymptote. And also we have to indicate x-intercept. That means point at which the graph cuts the x-axis. Then x-axis එක කපන තැනදී මොකද වෙන්නේ? Y equals to 0 වෙනවානේ. y-intercept එකේදී x equals 0 වෙනවා. x-intercept එකේදී y equals to 0. At x-intercept y equals to 0. At y-intercept x equals to 0. So here we have to find x-intercept and the turning point. So we already have found. So let's find horizontal asymptote and x-intercept. Okay. Right. Find in the horizontal asymptote. So what is horizontal asymptote, Lamai? Yes, limits of fx. We find the limits of fx when x tends to plus or minus infinity. We find, right? What we find is, we find to which value the graph tends to which value the y values tends to, when x values get closer to plus and minus infinity. Okay, x values plus infinity minus infinity langana kuda y values වලට මොකද වෙන්නේ කියලා තමයි බලන්න. Okay, let's see. Limits of fx. This is fx. This is fx, right? So we will write it 4x plus 1. මම expand කළාම ලියනවා main එක කවුද? x squared minus 2x. x squared minus 2x. When x tends to plus or minus infinity. Clear? Right. Now you divide all the terms by x squared. Right. So we will get here 4 over x plus, divide this by x squared, 1 over x squared, divide this by x squared 1, divide this by x squared, minus 2 over x when x tends to plus or minus infinity. So when x tends to this, when this denominator tends to plus or minus infinity, what happens to this overall fraction? This fraction tends to 0, you know, right? When the denominator tends to plus or minus infinity, this fraction tends to 0. So 0 වෙනවා, මෙයා 0ට යනවා. තේරෙනවද? So numerator will be 0 and denominator is equal to 1. So 0 over 1, it is equal to 0. So what is the horizontal asymptote? 0. But we are finding fx means y, right? Okay. So what happens to y when x tends to 0? So what is the horizontal asymptote? Yes. What is the horizontal asymptote? Y equals to 2. Sorry, y equals to 0. Y equals to 0. Clear? That is the horizontal asymptote. I hope you can understand this part, and then we have to find the x-intercept. So regular කියලා තියෙන ටික කොහොමද හොයන්න ඕනේ, right? X-intercept. At x-intercept what happens? Y is equal to 0, right? At x-intercept y x කැපෙන තැනනේ පුතේ. x-intercept කියන්නේ මේ වගේ. Clear? එතකොට ඒ වගේ points වලදී මොකද වෙන්නේ මේ? Always y value is equal to 0. Clear? That's right? So y equals to 0. At x-intercept y equals to 0. Then we coordinate හොයාගන්න we know the y value of the x-intercept. X-intercept එකේ y value එක අපි දන්නවා, it is always 0. We have to find the x value. ඉතින් මොකද කරන්නේ coordinates හොයනකොට? Always substitute in the main function. Main function එකේ substitute කරන්න. හරි. y කියන්නේ fx ට. හරිද? මෙයා 0 වෙනවා කියන්නේ. This is a fraction. A fraction is 0 when, yes, a fraction will become 0 when its numerator is equal to 0. Arthur may numerator is 0 when x when x equals to minus 1 over 4. Clear? When x equals to minus 1 over 4. So y equals to 0 when x equals to minus 1 over 4. Therefore, we get the coordinates of this thing, right, as minus 1 over 4 comma 0. Minus 1 over 4 comma 0. So that is the way to find all the details relevant to this graph. Clear? Okay. You can note down the things that you need, and then you raise hands please once you finish writing these things. Okay, then I can just easily move to the next part. If you have already done up to this point, raise hands. Finish it and raise hands. Okay, write the important things. Okay, shall we move on? Raise hand also still writing? Right, Lamai. So I wrote all the details that we have found here. Right, we found the vertical asymptotes as x equals 0 and x equals to 2, and then we found the local minimum is -1 comma -1, maximum half comma -4, x-intercept as -1 over 4 comma 0, and horizontal asymptote as y equals to 0, and we will need this chart as well. Right, so it is not needed to write all the things at the same place, just to it's easy for me to because I want space in the board, and also it is easy for me to teach. That's why I wrote it finally, all the things at one place, right? Okay, let's sketch the graph. Right. So this is the way to do, right? Take this as the y-axis. This is the y-axis, and draw the x-axis. This is the x-axis. Right. So as our first step, when you are drawing the graph, we have to draw the vertical asymptote and the horizontal asymptotes, right? So draw the vertical asymptote. X equals 0, x equals to 2. Mark them. X equals 0. Here, x equals 2. 2. This is the vertical. At these points, we have to draw the vertical asymptotes, right? I think I will use another color. I will use green. Look at this, Pute. 0, 1, 2. So at these points we have the vertical asymptote. So this is the way we have to draw. You draw dotted lines to represent the vertical asymptote, right? So these two are the vertical asymptote at x equals to, x equals 0 and x equals 2 are the vertical asymptotes. Horizontal asymptote we found as y equals to 0, right? Y equals to 0. What is the straight line? Y equals to 0. This passes through y equals 0. You know, when it is y equals means it is a horizontal line we have to draw, right? Clear? So that is the way to draw the horizontal asymptote and the vertical asymptote. Now, mark local minimum and the local maximum. Local minimum I got as -1 comma -1, and local maximum I got as plus half minus 4. Let's mark those ones also. -1 පුතේ මේ -1 local minimum. Just put a little mark. Then pencil එකේ නේද you're drawing using your pencil, right? So පොඩි mark එකක් දාගන්න minimum නේ. So this kind of curve you should get at that point. And then local maximum half minus 4. Half මේ තියෙන්නේ half minus 4. Minus 4. This is the local maximum. Here we have a maximum point for the graph. Clear? So මෙතන maximum එකක් එනවා. I hope you can understand. Right. Is that all that we know about the graph? We know the x-intercept also. No? X-intercept minus 1 over 4 comma 0. Minus 1 over 4. Minus 1 over 4 somewhere here. No? Minus 1 over 4. Minus 1 over 4 plus half plus 2 minus 1 minus 4. Okay, right, now let's sketch the graph. Then I will start from the minimum point. Okay, we'll start from the minimum point. So then here we have a minimum point. Here should increase it, sorry, and it should cross this point as well. Clear? This is the x-intercept. They have given that this is the x-intercept. And then, at vertical asymptotes, what happens? The function is undefined and function tends to the y values tends to infinity. Okay, plus or minus, y values tends to infinity. Right? That means now in this case it tends to plus infinity. Clear? It never cross this line, but it get closer to it, closer and closer, but still never cross. So you can represent it like this. Clear? And then how about this side? Now we found that when the x values get closer to minus infinity, that is what we found when we are finding the horizontal asymptote. We found something like this. We were talking about something like this. Limits of fx when x tends to plus or minus infinity. When x values get closer to plus or minus infinity, to which values does the y tends to what? Right? So y values ටික බලන්න. දැන් x values එන්නේ වැඩි මේ minus infinity යනනේ. එතකොට මොකද වෙන්න ඕනේ? Y values they get closer to zero. They get closer to 0. They never become they never cross this point. They get closer to 0. And then 0 to langana wage penna di. Can you understand? Eka meet වෙනවා දින්න එපා. I hope you can see it clearly. Right, like this. And your graph should be smooth as well. Right. So that's about that part. Okay, that's about the graph from minus infinity to 0. Clear? Now, from 0 to this side, let's draw the graph. Here we have a maximum point. Here we have a maximum point. Clear? එතකොට දැන් කොහෙද graph එක යන්න ඕන? Now it should go along the asymptote. දැන් asymptote එක දිගේ තමයි යට යන්න වෙන්නේ. එයාට තව turn වෙන්නේ නැහැ ළමයි. හොඳ එක maximum point එකයි තියෙන්නේ. You have only one maximum point and one minimum point. Right? So it has to go like this. Along the asymptote. When you get closer to 0, the values get closer to, values tends to infinity like this. Okay, there also you have to draw symmetrical වෙන්න ඕනි කියලා කරන්නේ. දැන් මේ values එන්න මෙහෙට ලඟ වෙනවා දින්න. clear? නැත්නම් මේ එහෙනම් mid point එකේ තියෙන්න ඕනනේ. Like this. Never touch the line but get closer to that line. Is it clear? Right. That is about the graph from 0 to 2. Then 0 to 2 part. Now we have to think about the graph part 2 to infinity. Then we need the intercept and the what we call this minimum point. And this part also we knew about the maximum point. But in this case we don't know anything. Clear? Right. Now, Lamai, at the infinity, at the vertical asymptotes, at vertical asymptotes, the values tends to infinity. Clear? එතකොට මෙයා මේ side එක මේ infinity එක කියන්නේ මේ පැත්තෙන් හරිය නැත්නම් මේ side එකෙන් හරිය. හරිද? plus infinity එකේ හරිය minus infinity එකේ හරිය ඉඳලා යන්න ඕනේ. And also, when we increase the x values, you know the values tends to 0. The values 0 to yanawa but horizontal asymptote. Right? So, the graph should be either this one or this one. Clear? This or this, not both, this or this. You have to identify which one is the correct thing. Clear? ඒකට තමයි teacher මේ chart එක use කරන්නේ. For that one, I am using this chart. Can you observe? We have this important fact in this thing, right? For the values which are greater than 2, we know that the tangents lie this way. The function should be a decreasing function. Clear? Function is a decreasing function, or the tangents lie this way. Clear? Again, this is about the values which are less than 2, right? This is about the values less than 2. Again, decreasing function. This is a decreasing function. This is an increasing function. Clear? Right? You can think about the tangents. Tangents me or the tangents me direction clear? For this one it happens. For this one, so this is wrong. This is the correct one. Is it clear? So that is the way to think about that. Right. So I will just erase this thing now. Now we observe for the values from minus infinity to minus 1, tangent में decreasing when known. Tangents में हम दिए बोलो. See, can you observe? Until minus 1 is decreasing. Okay, and then from minus 1 to 0, see, minus 1 to 0. It should be increasing and the tangents like this way. And increasing. Clear? Tangents like this way. Clear? And then see, from 0 to half, tangents 0 to half. 0 to half. See? Again, half to 0, it should decrease. And this case also we drew using the same fact, right? Right. Yes, and those can understand this now. Yes, Hannah, by substituting in the main function, right? Okay, I will explain again. Right. Okay, let me explain the graph again, right? Drawing the graph part again. I hope you can understand. We have to draw the maximum, vertical asymptotes and the horizontal asymptotes. Draw the vertical asymptotes and the horizontal asymptotes. That is the first task. Then, it was the one cue, me marks tika dagan, maximum minimum intercepts you just mark them. Right? Okay, I drew the, here we have a minimum point, and here we have a maximum point. Right? And also here we have the intercept. You can mark those things. Then you just start from one of the maximums or the minimum. So I started from this thing. Minimum. Right? So the curve minimum. Now you have to think about this part. Think like that. How we have to draw the graph. How we have to sketch the graph for the values which are less than minus 1. So you don't have any coordinates, but you know that x values x value tends to infinity. And then x values mean minus infinity and we found that limits of fx tends to 0. Values values are getting closer to 0. Y values are getting closer to 0. That is the idea of horizontal asymptote. I cross n values 0 to y values n 0 to can you see? Okay, so like this, it gets closer to the x-axis. Clear? Then from minus 1 to 0, how to sketch the graph? Think about that. Minus 1 to this vertical asymptote. You cannot cross the vertical asymptote. Okay, never we can cross the vertical asymptote. Why? Because at vertical asymptotes the values are undefined. Again, x value plot y value. Can you understand? Because when x equals 0, you know main function denominator is 0. So the function is undefined. No, we can't find a value, exact value. Is it clear? so definitely or දැනගන්න ඕන values tends to infinity. එතකොට ඒ වගේ graph එකක් දැන් මෙහෙම එනවා නම් so it is having a minimum point, definitely it should go along the asymptote to infinity. Clear? Right. එතකොට මෙතන maximum එකක්. හරි? මෙතනත් එහෙමනේ. Right? එතකොට මෙයා තව turn වෙන්නේ නැහැ. This cannot this just not turn this way and එහෙම ඉන්නේ නැහැ. එතකොට මෙයාත් මේ asymptotes ගාවදී asymptotes cross කරන්න බෑ. ඒක යන්න වෙන්නේ along the asymptote. Clear? And for the values which are greater than 2, you can have only two kind of graphs, starting, infinity and getting closer to 0 at horizontal asymptote, and minus infinity to get, getting closer to y values. Y values ගැන මම මේ කතා කරන්නේ හරිද? Y values start from minus plus infinity and getting closer to 0 මේ. එන්න 0 වෙනවා. එහෙම නැත්නම් මෙතන minus infinity ගෙන් පටන් ගෙන මෙහෙම වෙනවා. But still here, but the function is decreasing, you know. Right, for values which are greater than 2, function is decreases. නැත්නම් tangents තියෙන්නේ මෙහෙම කියලා හිතන්න. හරි. එතකොට මේ graphs දෙකෙන් මම කියපු graphs දෙකෙන් tangents මෙහෙම තියෙන්නේ. මේ පැත්තට එන්නේ. Only this one it will like this way. So this is the correct one. Can you understand now? Yes. Rest hand also can understand. Manisha, how about you? Okay. Usually, Hannah, for this part, you can get like less than 15 minutes, right? About 12 minutes. Clear? Because we have a second part also. Usually we keep like 25 minutes or 20 minutes. That a time like we can keep 25 minutes for one essay, right? I think the second part only, so you can just do it within 12 minutes, right? Once you practice, this is a very easy one, right? This is the easiest one. Clear? So these are the first graphs now we are drawing. That's why it takes me time to teach, because you are new to the lesson. Otherwise, that does not take much time to explain even. Is also still sketching the graph? You want more time? Okay, let's move to the last part of the question. Last part of the question. Question. Right. Now look at this, all of you. Using this graph, now you will get sometimes not. Sometimes you will get some extra part, right? After drawing the graph to do, that is not a difficult one. Definitely that will be something easy that you can derive from the graph itself, right? Okay, now this case they ask, using this graph, find all the values of x satisfying the inequality fx plus modulus of fx greater than 0. Okay, you have to find the x values satisfying the inequality fx plus modulus of fx greater than 0. Okay. Right. Now look at this, all of you. Right. See, fx plus modulus of fx greater than 0 when we have a clear? Right. So we have the graph for the fx function, right? We have the graph for the fx function. Okay. So first of all, we will identify what is this. Okay. Right. So now this will be 2fx if it is like this. Clear? Then modulus sign again pressure thing. We have to think about the thing inside the modulus sign now usually. Right? So you have to think about the case where fx is greater than or equal to 0. Okay? And when fx is less than 0. Okay? Now fx is equal to 0 කියලා අර break කරන්න පුළුවන් ළමයි. That is also okay. But කොහොමද මොකද වෙන්නේ? When fx is equal to 0 also we are writing the same thing now. So I got it just together. Right? Okay. Now when fx is positive, when the thing inside the modulus sign is positive, how can I write the sum? This will be also fx. So fx plus fx is equal to what? 2fx. Fx plus modulus of fx equals to 2fx for fx when fx is greater than or equal to 0. Clear? When fx is positive or equal to 0. I think you have a good idea about modulus, right? When the thing inside the modulus sign is positive, we are writing it as it is, right? But if it is negative, to remove the modulus sign, what you usually do? We multiply the thing inside the modulus sign by minus 1. Clear? Right. Now here the case is when fx is negative. When fx is less than 0, then this will become minus fx. So fx minus fx will become 0. Can you understand? This will become minus fx. This is equal to minus fx if it is negative. If the thing inside modulus sign is negative. Clear? So fx minus fx will give us answer 0. So we can have two answers. One is fx plus modulus of fx can be equal to fx for the when fx is greater than or equal to 0, or fx plus modulus of fx can be equal to 0 when fx is negative. fx negative වෙන වෙලාවට කියන්නේ y values නෙමෙයි තියෙන්නේ, y values negative වෙන වෙලාවට this function මේ අලුත් function එකක් නේ fx plus modulus of fx, this is equal to 0. When fx is positive, when y values are positive, it will be equal to 2fx. Clear? So here we are talking about this case. fx plus modulus අපි solve කරන්න තියෙන equal to මොකද්ද? fx plus modulus of x greater than 0. Right? fx plus modulus of fx greater than 0. ඒ මොන වෙලාවටද ළමයි? Right? Then fx plus modulus of fx either it can be 2fx or it can be 0, right? මේ දෙක එකක් නෙවෙන්න පුළුවන්. 2fx නැත්නම් 0. එතකොට positive වෙන්නේ මේ sum එක positive කියලා කියන්නේ for this case, right? Clear? එතකොට ඒ මොන වෙලාවෙදිද? This is equal to 2fx, and that is when for the fx for the y values which are greater than or equal to 0. එතකොට ඔයාලා ලියන්න ඕනේ මෙතනදී, right? This happens for the y values for the in the case where the function is greater than or equal to 0. Function is greater than 0 where? From where to where? Yes. Graph එක above the x-axis තියෙන points ලියන්න ළමයි. Right? Graph එක above the x-axis තියෙන y greater than 0 means y positive means. හරි? ඒ කියන්නේ දැන් fx plus modulus of fx ට answers දෙකයි. ඒ කියන්නේ මෙන්න පුළුවන් දේවල් දෙකයිනේ තියෙන්නේ. Either it can be equal to 0 or it can be equal to 2fx. එක 0 වෙනවා නැත්නම් 2fx වෙනවා. හරිද? එතකොට 2fx වෙන්නේ fx positive හරි 0 හරි වෙලාවට. Can you understand? Right? එතකොට fx greater than 0 වෙලාවටනේ. Can you understand? Right. එතකොට ඒ කියන්නේ මෙයා positive කියන එකනේ. fx positive වුණා. This answer will be always positive then. For which values? For the y values which are greater than 0. Clear? So y values greater than 0 වෙන මොන වෙලාවටද ළමයි? y values greater than 0 කියලා කියන්නේ පුතේ මේ above the x-axis. Graph එක above the x-axis තියෙන්නේ -1/4 to 0 and from 2 to infinity. From 2 to infinity. Right. Here we have to separately think, no? When fx equals to 0, what will happen? The answer will be 0, ne? Yes. Sorry. When fx equals to 0, the answer is 0, right? Either fx greater than 0 when ne? And now, for which values? -1/4 to, we can't take -1/4 thing to 0. 0 කොහොමද ගන්න බෑ ඉතින්, right? Function is undefined at 0, no? Union 2 to infinity. 2 to plus infinity. This is the answer. Right? ඔයා බලන්න ඕනේ y values positive වෙන වෙලාව. fx positive වෙන වෙලාවට තමයි 2f answer එක 2fx කියලා එන්නේ. මෙයාගෙන් එන answer එක 2fx කෙනා. fx positive නම් 2fx උත් කොහොමද positive? ඒ කියන්නේ මෙයා positive කියන එකනේ. Clear? When fx equals to 0, this answer will be 0. When fx is less than 0 also, මෙයා fx minus fx වෙලා 0 වෙනවා. Clear? අපි බලන්නේ y values positive වෙන වෙලාව. y positive වෙන වෙලාව y කියන්නේ fx ට, fx කියන්නේ y ට. So y positive වෙන වෙලාව කියන්නේ මෙයා positive වෙන වෙලාව. කියන්නේ මෙයා positive වෙනවා. So that means we have to talk about the case where y values are greater than 0. That is when the graph is above the x-axis. ඒ තියෙන්නේ මෙන්න මේ minus infinity to 0 වෙනකනුයි 2 to from 2 to infinity. Clear? That's why x is an element from this to this. Yes, and those can understand the fact. Okay, now this question, right? Okay, I will help you in the first part. I'll help you in the first part, and then you can continue drawing the graph part. Okay, sketching the graph one. Yes, this question we will do. Right. Question number 2. Right. Let fx is equal to, okay, I will help you to do this first thing, how to, otherwise it will take time now. So I will do the first part first, and then sketching the graph. To sketch the graph, I will give time, right? Okay, now let fx equals to, now this time it is given as, given with some unknown terms p and q, the function. We have to find p and q. We will show that p equals to -3 and q equals to 2. Clear? Right, let's see. Let fx equals to px plus q, x minus 1, x minus 2. Right? Where x is a real number and it is not equal to 1 and 2. it is given that, and p and q also given as real numbers, it is given that the graph of y equals fx has a stationary point. And they have given us a stationary point. Usually we find stationary points now. Clear? Stationary points. Now this time in this question, they have given us a stationary point. One of the, we don't know, sometimes they may be, yeah, according to the function, see, we have two stationary points. But here, they have given one of them. Clear? And using that data, you have to show that p equals to -3 and q equals to 2. Clear? We have to find we have to show that p equals to -3 and q equals to 2. Okay. Read the question well. Read that first part well again, y'all. And latest the board. Now see, Lamai, the function is given as this. Px plus q over x minus 1, x minus 2. Clear? This is the given function. It is given that the graph fx has a stationary point at 0, 1. Now, at the graph is having a stationary point. That means the graph is having a minimum or a maximum. It can be a minimum or it can be a maximum at this 0, 1. Coordinate of the minimum or the maximum, coordinate of this stationary point, sometimes maybe a this kind of a one, right? Point of inflection, where you have a like this. Okay. However, they have given the stationary point coordinate as 0, 1. Okay. First advantage is this, right? They have given a coordinate on the graph. Graph coordinate. Can you understand? That is a coordinate on the graph. That is a point on the graph. You can just substitute. Instead of y, we can write 1. Instead of 0, instead of x, we can write 0. Right? Because this is the coordinate on the curve, means it satisfies this equation of the given function. Clear? Substitute, you can have one equation in terms of p and q. Okay, right? Actually, here when you substitute 0, you can find the value of q. Okay, right? We will substitute. Right, 0, 1. Right, satisfies y equals to px plus q over x minus 1. It satisfies this equation. Why? Because it is on the curve. The curve could need the points. And the y value substitute y equals to 1 and substitute x equals to 0. So p into 0, it is 0 plus q over 0 minus 1 minus 1, 0 minus 2 minus 2. Is it clear? Then very easily we can find that q equals to plus 2. Raise hand those who can understand. Right? So basically 0, 1 is the point on the curve. We could in the point that particular point, you don't need any differentiation knowledge there. Right? That point satisfies the equation of the function. Clear? That's it. Right? Substitute karana මේ y value එක 1 වෙන වෙලාවට x value එක 0 කියන එක meaning නේ. Clear? So like that we can find the value of. Okay, then what is the other way? What we have to do to find q? මොකද කරන්නේ q හොයන්න. Sorry, p හොයන්න. What we can do? So we know that this is a stationary point. So we know this fact. At stationary points, what happens? F dash x is equal to 0. At stationary points, f dash x equals to 0. So we will find f dash x, Lamai. Clear? We will find f dash x first, and then we will use this fact. Okay? Right. Let's find f dash x. I will write it here. See, f dash x equals to denominator squared x minus 1 squared x minus 2 squared. Okay, then denominator into differentiate the numerator. Denominator is x minus 1 x minus 2 and differentiate the numerator with it, we will get p minus px plus q into, you will differentiate the denominator. Denominator how the mean? Yes, denominator is equal to what? X squared minus 3x plus 2. X squared minus 3x plus 2. Differentiate that. We will get, when you differentiate x squared, 2x. When you differentiate minus 3x, minus 3, 0. Clear? So we will get like this. Okay? Right. So we can simplify this further, the numerator. Here we have x minus 1 whole thing squared, x minus 2 whole thing squared. And we know the fact that q ke value එක දන්න ඕනේ. Q කියන්නේ කවුද? Q is 2. This is actually x squared minus 3x plus 2 into p. Okay? Minus px, instead of q I will write 2 now, into 2x minus 3. Like this. This is f dash x. Okay, this is f dash x. Right, now what we can do? Yes, Lamai? We will use the fact that f dash x is equal to 0 at stationary points, right? So we will use that fact. At stationary points, f dash x is equal to 0. So f dash x is a fraction this time. F dash x is a fraction. So fraction equals to 0 means this numerator is equal to 0. Clear? Numerator equals to 0. So let's try the numerator. X squared px squared minus 3px plus 2p. Clear? Expand this and write px into this minus 2p x squared px into minus 3 plus 3p x squared with this minus outside. 3px කියලනවා. ඊට පස්සේ මෙතන 4x කියලනවා. You get plus 4x here. And here we will get minus 6. Minus 6 equals to 0. So this is how we get. Is it clear? So we can further simplify this. They get cancelled. Right. px squared minus 2px squared would be minus px squared. Right. Plus 2p. Sorry. Plus 4x. Plus 2p minus 6 equals to 0. So this is how we get. So yes, we have to find p. Right. So we know the x value. Then අපි දන්නවනේ stationary point එක x value එක. හරි? දැන් මෙහෙම අපිට f dash x එක 0 කියලා එනවා කියලා එනවා. දැන් මෙහෙම අපි කියන්නේ f dash x එක 0 වෙනවනේ. මේ වෙලාවේදී. At this point f dash x is equal to 0. At stationary point f dash x equals to 0. And also we know the x value at that one. Minus 4x. This one, yes, I see. Yes, no, that is minus 4x. I'm sorry. This is minus 4x. Thank you. Right. Okay, now at stationary points f dash x is equal to 0. Right, now you know the x value at the stationary point. Right, we know x is equal to 0. So you can substitute x equals to 0, right? We can write substitute. Yeah, we can write like this. Substitute x equals to 0. So this one will become 0, this becomes 0. So we will get the 2p minus 6 equals to 0, where p equals to plus 3. Okay, because we know the coordinate of the stationary point. At stationary point, this is equal to 0. X equals to 0. That's right. Is it clear? You can apply it here itself also, no? X equals to 0 කියලා දාලා මෙතනින්ම answer එක කරගන්නත් පුළුවන්. Or else here we can write f dash x equals to 0, and so this part is equals to 0. F dash x 0 means numerator of the fraction equals to 0, that's why. And then we get this, then we substitute x equals to 0. Clear? Because at stationary point x equals to 0. That's the way to identify this. Right. Then let's move to the yes, Sunny, sorry. Here also positive. I have done a mistake, right? So then minus 3, right? Then for other teacher multiply minus 6 with this minus plus 6, right? Right. So we get p equals to minus 3 there. Okay, now we know this one. Then p then q. Now we can write the original function. So fx equals to what? Fx we can write as minus 3x plus 2 over x minus 1, x minus 2. This is fx. We also can find f dash x. Okay, so as a next step, they ask you to find f dash x, right? For these values of p and q, show that f dash x equals to this thing they have given, right? Okay, let's find f dash x now. F dash x then I hadanna yanna ඕනේ නැහැ පුතේවා මෙතෙන්ට වෙනකම්ම හදන්න තියෙන්නේ. You have done up to this point, so you just substitute to this line. Okay, that is f dash x equals to x squared minus 3x plus 2. Okay, yeah, we will write this one, no? F dash x. May f dash x එක අපි simplify කරගෙනත් තියෙනවනේ මෙතන යා වලියුම්. Otherwise we have to write all this stuff, no? Again we will write this one. We have the simplified thing, no? F dash x equals to this plus 2p plus 6 over x minus 1 whole thing squared, x minus 2 whole thing squared. Clear? Now so instead of p you can write minus 3, instead of q you can write 2. P then minus 3. See, minus 3, that will become plus 3x squared, and minus 4 into minus 4x, 2 into p, minus 6 plus 6, yes, over x minus 1 whole thing squared, x minus 2 whole thing squared. So these two get cancelled, and finally when you take x out we will get 3x minus 4 over x minus 1 squared, x minus 2 squared. So this is what they are asking you to rewrite. Clear? Right. I hope you can understand the sum. Right? Here we use the fact that regular then extra factor regular stationary point that means they have given us the coordinate of on the graph. Therefore you can just substitute those values in for y and x. Again, x equals 0 not y value 1 meaning you can just substitute those things here, and we can write this equation and find the value of q. And the next case I'm going to use is they mention that this is a stationary point. Stationary point f dash x you have to find f dash x, and we know that at stationary point f dash x equals to 0. F dash x is a fraction is 0 when its numerator is equal to 0. F dash x is 0 when numerator is 0. Is it clear? And also we know that at this time x is equal to 0. X value is 0, right? So once you substitute that, we will get p equals to minus 3, right? Okay, now you sketch the graph. What you have to do is actually you have fx now, you have f dash x, fx in nama, f dash x in nama. So what you have to do is you have to find the increasing and decreasing intervals and sketch the graph indicating asymptotes and turning points. Indicating asymptotes and turning points. Okay, start. Sketch the graph indicating asymptotes and turning points. Yeah, I will give you like 5 minutes to try to write the data and all. Yes. To write data, I mean to find the data needed to draw the graph, sketch the graph. You just find the asymptotes and the turning points, those things, increasing and decreasing intervals, and then I will discuss those things and give little time to sketch. Okay, right, let's do like that. Okay, Lamai, Miriam, listen me, because f dash x is this, right? F dash x is this, right? So its numerator, we simplified up like this. Okay, this one's numerator we simplified as this, and that numerator is this. We wrote here, and I simplified it up to this. Okay, so we have to simplify it the whole thing again. If I start from here, that's why instead of this line, this I wrote this. Can you understand? And just it is the same f dash x, right? And I substituted the values. Can you understand? Okay. Dear students, raise hand those who need this. I mean, those who are still writing this one. Shall I erase it now? Okay. On. Right. See, now we know this thing, right? F dash x also we found that is equal to x into 3x minus 4 over x minus 1 squared, x minus 2 squared. Right? Okay, you have to find the intervals on which fx is decreasing and intervals on which fx is increasing, and then sketch the graph indicating asymptotes and the turning points. Okay, let's see. Right. So first of all, we have to find increasing and decreasing intervals. So what is our first step? Finding the vertical asymptote, right? Vertical asymptote. Right. As my first step, I'm going to find the vertical asymptote. Right. See, now this is the function, consider this function, this is the function that we are going to draw the graph. This function will be undefined, okay, and tend to infinity when the denominator tends to 0. When denominator equals to 0, this will be undefined, let's say, right? Denominator equals to 0 at which, for which x values, right? For x equals to plus 1 and x equals to plus 2. For x equals plus 1 and x equals to plus 2. So x equals 1 and x equals 2 are vertical asymptotes. Is it clear? Right. Then, sorry, here we found the values. Now we found this as minus 3 and plus 2. Am I correct? P as minus 3, Q as yes plus 2. Right. Okay. So vertical asymptotes. Then we have to find the stationary points. So at stationary points, f dash x is equal to 0. F dash x equals to 0. So f dash x is equal to 0 at x equals to, that is when what, x equals to 0 and x equals to 3 over 4. I'm sorry, 4 over 3 here, plus 4 over 3. Clear? Plus 4 over 3. This one actually we already know, right? They previously mentioned about the stationary point. So that is this. Coordinates because we already know the coordinate, that is 0, 1. It is given no? At 0, 1 it is there is a stationary point. But still we have to confirm whether it is a minimum or a maximum. And here this one is a new other stationary point. Right. So what is the next step? Yes, you all draw a number line like this and then mark all these things. We have 4 values, vertical asymptotes and these things. You mark them in order, right? So we get 0 first, right? And then 1 and then 4 over 3 and then 2. Okay, right. Then write the intervals minus infinity to 0, 0 to 1, 1 to 4 over 3, 4 over 3 to 2 and 2 to infinity. Is it clear? Right. Then you observe what? Here we are observing the sign of f dash x. You observe the sign of f dash x. F dash x sketch කරගන්න මම numerator එක විතරක් ඇඳ ගත්තත් ඇති මොකද denominator එක අපි positive වෙනවා කියලා දන්නවා because denominator cos, we have cos there, right? So it is always positive. No need to write it here, draw it, but still if you want always positive, no? So I will just write positive. Okay, because positive does not affect the sign, right? Plus can divide kira kila sign එක වෙනස් වෙන්නේ නැහැ numerator එකේ තියෙන එකයි. But if it is minus, definitely it will change the sign. So here mention. This time it's okay, right? If you don't mention even. Right. To substitute draw like this, then it is easy for you. Denominator always positive. Okay, now tell me a value which is less than 0. Minus 1. Substitute minus 1 in next, negative. Substitute 3 times minus 1, minus 3, minus 4, negative. Is it clear? Right. Then substitute the value from 0 to 1. What is it? Half. Substitute half in next, that is positive. And 3 over 2 means 1.5 minus 4 is negative. Clear? 1 to 4 over 3. This will be always positive, right? X may have more positive. First, less than 0, substitute in next negative. For the other cases, positive, right? Then 1 to 4 over 3. Yes, we will substitute 1.1 here, right? So 3 into 1.1, 3.3 minus 4, negative. Clear? Then 4 over 3, right? You can substitute what? 2 to 1.9 less, 1.9 less. So definitely we will get the answer positive this time. Clear? Then a value which is greater than 2 also, this will be positive. Is it clear? Right? So you can have a rough idea about 4 over 3. Okay, that is 1.3 something. Value with substitute. Right. Then minus into minus plus. Plus into minus minus. Plus into minus minus. Plus into plus plus plus. Like this. So how the gradients appear? Tangents appear, right? Tangents this way. Negative. Gradient negative, tangent to this direction. Gradient positive, tangents this way. Gradient positive, tangents this way. Clear? So you can now mention they are increasing or decreasing. In words you write increasing, decreasing, decreasing, increasing, increasing. Clear? Like this. Raised hands also got correct up to this point. Yes, raised hands also got correct up to this point. Okay, most of you have, only 7 of you got it correct. Can you please raise hands again? I missed it. Those who got correct, please. Nanishi, Minori, still doing, is it? Okay, now, right. Now, just again mark the stationary points, right? This is the stationary point and this is the stationary point, so they are important. And see, increasing, decreasing, decreasing, increasing. So here increasing, decreasing means what kind of a point is it? Yes, there we have a local maximum. Local maximum. Here it forms local minimum. Local minimum. Clear? So local maximum at where? 0, 1. No need to find it. We already know 0, 1. This one we have to find. No? Local minimum. Right? At x equals to what? 4 over 3. We have to find what is y. Okay, y value එක හොයාගන්න. Okay, you have to find the value of y. How to find the value of y? You just substitute it here. Right, मैं substitute කරන්න. So y will substitute it here and write minus 3 times 4 over 3. When x equals to 4 over 3, we will find the local minimum. So substitute 4 over 3 plus 2 over 4 over 3 minus 1, right? 4 over 3 minus 2. 4 over 3 minus 1, 4 over 3 minus 2. So 3 and 3 get cancelled. Here we'll get minus 4 plus 2, it is minus 2, right? 4 over 3 minus 1 means plus 1 over 3. And here 4 over 3 minus 2 means 4 minus 6, minus 2 over 3, minus 2 over 3. So you can see this they get cancelled, minus minus, they get cancelled, and then we get the answer as 9. Okay, so here we will get the answer as 9. So the coordinate is 4 over 3 comma 9. Correct answers please. Local minimum, those who found local minimum. Yes. Very good. Okay, so practice එකක් විදිහට හැම වෙලේම chart එක ඇඳපු ගමන් මේගොල්ලන් හොයන්න. Definitely you have to find them not to sketch the graph. So you just write it here, local maximum. Here it forms the maximum, and then identify what is the coordinate of the maximum. Clear? And then this is, here it forms the local minimum, and then you identify what is the minimum point, right? Coordinates of the minimum point. That is the way to do, right? Then you don't miss any fact that you need to find, right? Okay, so like this, I substituted in the main function and found the answer. Clear? Right. Substitute x equals 4 over 3 in this and find the answer as 9. Okay? Right. Okay, now what we have to do? What is the next step, Lamai? Yes, we have to find, we already have the vertical asymptote, and we found the turning points, and then we will find what are the horizontal asymptotes and the turning points and the asymptotes only we have to find in this one, no? Yes. This is the vertical asymptote. We already have the vertical asymptote, and we found the minimum and the maximum points, the turning points, and now we have to find the horizontal asymptote. Let's find that horizontal asymptote. Okay, horizontal asymptote. Right. So that is when limits of fx, limits of the function when x tends to plus or minus infinity. We have to find the limits of the function when x tends to plus or minus infinity. Okay, so that is limits of 3x minus 2 minus 3x plus 2 over x squared minus 3x plus 2 when x tends to okay, Amai. So, sorry, right? Now listen to me. Limits of minus 3x plus 2 over x squared minus 3x plus 2. එතකොට මෙයා මම expand කළාම ලියගත්තා. I just expand this and dot, right? The main function. So I expand this and then I wrote it here. Clear? Right. Okay. Now I will divide all the terms by x squared. Right. See, minus 3 over x plus 2 over x squared divided by x squared minus 1, 3 over x plus 2 over, divide this by x squared, this. Divide all the terms by x squared. When x values change to plus or minus infinity, this fraction tends to 0, you know. And this is 0, this is 0, 0, 0, 0 over 1. So this time also it is 0. So what is the horizontal asymptote? Y equals to 0, right? So we get the horizontal asymptote as y equals to 0. Y equals to 0. Is it clear? Right. So using these facts, we will sketch the graph. Right. I will give you few minutes to sketch the graph. Raise hands already. Those who have already finished sketching the graph part also. Right. Very good. Okay. We will check that. Others, start to sketch the graph, please. Okay, we found that horizontal asymptote is y equals to 0. Right, now we will sketch the graph. Look at this, all of you. Right, so as our first step, what we have to do? Yeah, we have plus 9 also in y-axis, so I will just draw x-axis here, like. Yes. First of all, what is our first step? Draw the vertical and the horizontal asymptote. That is what we have to do first. We have to sketch, we have to draw the horizontal and the vertical asymptotes. Clear? Right. So what are the vertical asymptotes? X equals 1, x equals to 2. X equals 1, x equals 2. X equals 1, x equals 2. This is the vertical asymptote. And this one. Okay, then the horizontal asymptote. Y equals 0. We found it as y equals 0 here. So that is the horizontal asymptote. Okay, right. Now we will mark the local minimum and the local maximum. Right, we have both the maximum and the minimum point. So we will mark the maximum point 0, 1. 0, 1. So its origin and 1. Right. Here we have a maximum point. So I'll just draw a mark like this. Okay, that is the maximum point. Then what is the other one, Lamai? We have the minimum point at 4 over 3 9. 4 over 3 comma 9. Right? So 1 here. 4 over 3 we will mark in this point like this roughly, right? 4 over 3 comma 9. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I will mark 9 roughly here. Right? Let this be 9. Clear? Right. So there we have a minimum. 4 over 3 comma 9. There you have a minimum point. So we will mark like this. Is it clear? Right. That's all, no? Now we have to sketch the graph. Right. Now observe this. Now we will start from here. Here we have a maximum point. Right? Then maximum point you just think about this side what we have to do. Maximum point main side from the maximum point this side what we have to do. Right. See, from here we are now increasing, we are the x values, actually we have to consider that x values tends to minus infinity. So we know that when do we find this horizontal asymptote? What is the horizontal asymptote? Limits of fx when x tends to plus or minus infinity. So we know that y values tends to 0. Clear? Like this. I have to draw. Clear? Mama. The values tends to infinity. And then the values infinity lang so I will use black pen to sketch the graph. So this is, let's say this is 1. So this is the maximum point. So it like this, it gets closer to 0. It gets closer to 0 and then 0 to lang but it never cross this line, it will just get closer. Is it clear? It gets closer to this, like this. Then this point, this way, then the maximum turn. Okay, and also now we are getting closer to the now we are going to draw about the now the part that we are going to sketch is for the interval 0 to infinity. So 0 to 1. 0 to 1 when the values get closer to 1, the y values get closer to infinity. Clear? The y values tends to infinity, we say. Right. Okay, we can cross the horizontal asymptote at these middle areas, not at these infinity things. Right? Again, infinity when the x values tends to infinity, we can't cross the horizontal asymptote, but middle areas it's okay, right? That is not infinity now. But here we can never cross vertical asymptotes. Vertical asymptotes cross because the functions get undefined at those points. Clear? At those lines, right? See, Now about this, the මේටික ඉවරයි. From here to here we have sketched the graph. Now from 1 to 2 what will happen? 1 to 2. See, මෙයාට දැන් මේ යන්න තරන්නේ නැහැ නෙමෙයි. It has to go along the asymptote definitely. Clear? It has to go along the asymptote. මෙහෙට හැරිලා මෙහෙම එන්නේ නැහැ නේ ළමයි. Right? This one also same. Get closer to asymptote. When the values get closer to 2, when the x values get closer to 2, y values change to infinity. Right. How about this side? You can have only two graph parts. I mean, from 2 to infinity, you can have only two types. Either this one or this one. Clear? Which one out of them? First one or the second one? Right? From which thing you have to think about it. කොහොමද හිතන්නේ කියන්නේ? මේ තියෙන පුතේ මෙතන ලියලා. It is increasing. You say that it is increasing, right? Or else the tangents should lie this way. මෙහෙම තියෙන්නේ tangents. The graph is increasing. Increasing එක කියන කවුද මේ? n values වැඩි වෙන්නේ මෙයාගේ. මෙයාගේ n values අඩු වෙනවා. Clear? So this is the graph. දැන් tangents තියෙන විදිහ හිතන්නේ මේ මෙහෙට තියෙන්න ඕන tangents. Okay, so this is the graph for that. Rest and those who got this correct. Yes, very good. Hope others can understand, right? Rest and those who can understand this well now. How I sketch it. How? Yes, very good. Yes, that is correct. Hana, very good. You're doing this part means actually you can score about 100 marks or 90, like nearly almost 100 sometimes, right? Now we will move to the next part of the question, right? We can see inequalities to solve using the graph, always you try to form the function or graphic ඇඳලා තියෙන්නේ මෙයාටනේ නේ fx නේ. I mean you have drawn the graph for this fx no, this function no. So using the graph you have to do the sum, you have to write the answer for the question using the graph. Clear? Then you try to form this. Clear? Right. I will divide both sides of this equation by, so we consider here x is not equal to 1, x is not equal to 2, it is given in the at the beginning. So I will divide both sides of the equation by x minus 1, x minus 2. Now we will get like this, x squared equals to 2 minus 3x over x minus 1, x minus 2. So what is this? Minus 3x plus 2 minus 3x plus 2 over x minus 1, x minus 2. So isn't it the same function? So here they tell that the given function, consider the case where fx is equals to x squared. You have to find the solutions for this equation. So however, fx means this curve. Clear? You have to find not the solutions here, we have to find number of solutions that satisfy this equation when fx, when the function fx is equal to x squared. So we can separately sketch the graph of x squared, right? Can you understand? මේ functions දෙක මේ function එක මේ function එකයි අපි අඳපු මේ තියෙන අපි graph එක sketch කරපු function එක this one. හරිද? එතකොට මෙයයි fx එක අපේ එක්කෙනයි අපේ graph එකයි මෙන්න මේ x squared එක equal වෙන point equal වෙන වෙලාව. Clear? Now you consider we have two curves, y equals x squared and y equals to fx. This one, y equals to x squared and y equals to this. හරි? එතකොට දැන් මේ equal වෙනවා කියලා කියන්නේ මොකක්ද? y values දෙක equal වෙනවා කියලා. y values equal වෙනවා කියන එක. මෙයාගේ y values මෙයාගේ y values වලට equal වෙන වෙලාවල් ගැන අහන්න. Clear? So you have to find how many solutions are there. So we can roughly sketch the graph of y equals x squared. In this year, they have given marks for sketching the graph of y equals x squared on this curve also. Right? So we will get this kind of a curve. Right? මෙයාලව cross වෙන්නේ නැහැ මොකද ළමයි මේ at x equals to 2 for the x squared graph the value is 4 not 9 නේ 9 ඒ හරියට යන්නේවත් නැහැ. ඒතර මෙහෙන් cross වෙන්න ඕනේ. 4 වගේ හරියකින්. This is the y equals to x squared curve. Clear? So 2 වලදී 4 නේ value එක. When x equals to 2, y equals to what? 4 squared, like that. Therefore it goes like this. So how many times does it cross this graph? Y equals fx function එක කීපාරක් meet වෙනවද? Only twice. Can you understand? So how many real solutions? 2 real solutions. ඒ කියන්නේ ඔයාලා බලන්න දැන් මේ y මෙයා y කෙනෙක් කියලා ගන්න. මෙයා අනිත් y y equals to x squared and y equals to this. Those are the two functions you have. Clear? එතකොට මේ දෙන්න equal වෙනවා කියලා කියන්නේ equal y values වෙන වෙලාවල් graph දෙකේම. They have the same y value. This graph and this graph, black color graph and this green color graph both have the same y value at this particular point. So we have this solution as this x value as the solution of it. And here also මේ graph එකටයි මේ graph එකයි equal වෙන තැනක් මේක. එකම y value එකේ වෙලාවෙදී. Same y value. Can you understand? Clear? වෙන කොහෙදවත් මේ green color graph එකයි එකතු වෙන්නේ නැහැනේ. Right. Can you raise hand also can understand the fact? Two real solutions. බලන්න ඕනේ ඒ දෙන්න meet වෙන තැන් කීයක් තියෙනවද කියලා. You are familiar with these kind of things because we have drawn modulus graphs, modulus equation solving කරන්න පුළුවන් අපේ graphs use කරලානේ. So when we equal to modulus functions, what we usually do? Using the graph equation as solve කරන්න කිව්වොත් intersection points කීයක් තියෙනවද කියලා අහන්නනේ. Graphs දෙකට same thing. Right? Okay. Okay, Lamai. Now you all try question number 3. Okay, students, so in this question, let fx, now here also this time they have given an unknown term x squared plus x plus p over x minus 1 squared. It is given that the graph of y equals fx intersects its horizontal asymptote at a point with the x coordinate x equals minus 1 over 3. Let us show the value of p equals to 2. Okay, now that means it is given that the graph of y equals fx intersects its horizontal asymptote. The horizontal asymptotic intersect x equals minus 1 over 3 here. Okay, that means you know, as I told you, the graph can intersect horizontal asymptotes. No? Infinity when it tends to x, when x tends to plus infinity and minus infinity, other times in the middle areas of the horizontal asymptotic cross කරන්න පුළුවන් graph එකට. එතකොට එන්නේ ඒ x coordinate එකක් තමයි දීලා තියෙන්නේ. They have given us the x coordinate of that particular point. Clear? Right. Okay, so you have to show that p equals to 2. Let's move on. This is the function given fx equals to x squared plus x plus p over x minus 1 squared. Clear? Now you have the graph, let's say. Image graph and we have a horizontal asymptote in this side. Where is the horizontal asymptote? I don't know. 0 just to think. And also at x equals to 1 over 3, we have a graph, and this graph moves from what? Moves to the, crosses the horizontal asymptote. Horizontal asymptote cross karana. Is it clear? Right? Then what we can do? Yes. So at that particular coordinate, right, we should get what? The horizontal asymptote, value of the horizontal asymptote. When you substitute x equals 1 over 3, when we substitute x equals 1 over 3, we should get what? The horizontal asymptote. Or horizontal asymptote n node. Clear? When at x equals to 1 over 3. Again, may y value we can know because it is the point on the graph. No? Then may graphically then when you substitute the value of x equals 1 over 3 in this x, right? What should be your answer? Your answer should be equal to what? The horizontal asymptote. right? Horizontal asymptotic value එක දැන් මෙතන 2 නම්. So what is the horizontal asymptote? Y equals to 2. That is what you have to understand. Clear? Don't me rough graph එකක් අඳින්න. ඇඳලා roughly අඳින්න ඕනේ නැහැ. Just to think it is rough work actually. At when it is x again listen, when it is x equals to 1 over 3, they say we have a horizontal asymptote and the coordinate at that particular coordinate, the graph cuts the x-axis. Graph cuts the horizontal asymptote. Then for this x value, graph එකේ දැන් මම මෙතනට x මේ x value එක 1 over 3 when you substitute in this function මේ function එක වල substitute කරාම y value that you get should be equal to what? The value of the horizontal asymptote. Is it clear? Raise and those who can understand that. We will find the horizontal asymptotes. We horizontal asymptote හොයමු. එතකොට තේරෙනවා. We can find the horizontal asymptote even without knowing p, right? No problem, right? See, limits of fx when x tends to plus or minus infinity, right? So that is limits of x squared plus x plus p over x squared minus 2x plus 1 when x tends to plus or minus infinity. Clear? So there we get divide all the terms by x squared. So here 1 plus 1 over x plus p over x squared, 1 minus 2 over x plus 1 over x squared, dividing all the terms by x squared. So you can see all these things tends to 0. Therefore, we are getting 1 over 1 as the answer. Therefore, it is 1. Now, this is the horizontal asymptote. What is the horizontal asymptote? Y equals to 1. තේරෙනවද? අන්න එතකොට ඔයාලට හම්බෙන්නේ මොකක්ද? y equals to 1 කියලා නම මෙතන මේ horizontal asymptote එක. Clear? Then what you get there? Yes, we get the coordinates of this particular point. ඔය intersect වෙන point එක තියෙනවානේ cross වෙන. හරි එන්නේ point එකේ coordinate එක තමයි 1 over 3, 1 කියලා. Now you can substitute instead of x we can substitute 1 over 3, instead of y we can substitute 1. ඒ reason එක මොකද්ද? Because this is the point on the curve. ඔයාගේ graph එක උඩ ඉන්න point එකක් මේක. මේ teacher බොරුවට graph එකක් කියන්නේ නිකන් මෙහෙම line එකක් ඇඳලා මේ cross වෙනවා කියලා වෙනවා. එතකොට මේක can you understand? What you have to understand it is a point on the curve. So that should satisfy the equation. ඒ කියන්නේ x equals 1 over 3 වුණාට y ගේ value එක 1 කියන එක. ඒක දැම්මම p වෙහෙව්වා. Clear? That is the so if you have the idea, even though they little bit give these type of questions these days, these are most recent one. I think yes. හරි ඉතින් ඒක නිසා දැන් මේ වගේ අර පොඩි එහෙම questions are previous years you can see that they just ask you to directly sketch the graph, differentiate it and then sketch the graph, but nowadays in these recent papers they usually give these kind of first part also. Clear? But if you have the correct idea what is the horizontal asymptote, okay, what happens like when you have a coordinate and if you get the other one, that means that if that particular coordinate is on the curve, that means it satisfies the particular equation. ඔය වගේ basic idea එකක් තියෙනවා නම් හරියට, then I don't think that they are difficult things, right? Then teacher sketch කරලා පෙන්නනවා. ඒ වගේ rough sketch එකක් you can just go for those kind of methods, right? Okay, so we found that this is the horizontal asymptote. Clear? So we can write like this, see, coordinate, right, coordinate of the intersection point. Therefore, the coordinate of the intersection point of what? The graph of fx, and horizontal asymptote. Clear? Is given by what? X value එක sorry x equals to minus 1 over 3 and horizontal asymptote we got as 1 කියලා. Can you understand? So we will get like this. You can just have a rough idea about this one. මේ වගේ පොඩි rough sketch එකක් හදින්න තේරෙනවා කතාව. We have the horizontal asymptote, assumed horizontal asymptote. just මේ නිකන් curve එක මෙහෙම අදින්න. ඒක තේරෙනවා මේ. minus 1 over 3 teacher අනිත් පැත්තේ අඳගත්තනේ. sorry මේ පැත්තේ minus 1 over 3 නේ. මෙන්න එතකොට මෙහෙම කර්ව් එක මෙහෙම කට් කරනකොට මෙතන clear? This is the vertical asymptote, the coordinate. Okay, so now we can substitute it there, right? We know that y equals to x squared plus x plus p over x minus 1 squared is our equation of the graph, right? එතකොට මෙතන 1 y එකට 1 x එකට -1/3 දාන්න. -1/3 squared means what? 1/9. X means -1/3 this time plus p over -1/3 minus 1. -1/3 minus 1 minus 4/3 over squared. Clear? So now we can cross multiply here. We will get 16/9 equals to 1/9 minus 1/3 plus p. Okay, so we can subtract here 15/9 plus 1/3 equals to p. Simplify further 3, 5. So we have 6/3 means p equals to 2. When we simplify, we can find that p equals to 2. Once you simplify this equation, however, whatever the method you use, you can find that p equals to 2. Raise hands also can understand this. Make a තේරුණාද? Can you understand this? Clear? So they say that horizontal asymptote, the graph crosses the horizontal asymptote at x equals -1/3. So teacher horizontal asymptote එක හෙව්වා, we found that horizontal asymptote is equal to 1. horizontal asymptote එක 1 කියලා නම්. හරි? එතකොට මේ තියෙන්නේ graph එක දැන්. මේ බොරුවට හිතනවා curve එකක් තියෙනවා කියලා, just like this, right? So like this you have a curve, and at -1/3 is here, -1/3 is here, and 1 is here. Then horizontal asymptote එක තියෙනවා. We found it now. Horizontal asymptote. So point at which they intersect is -1/3, 1. Clear? ඒක අපි දැන් මේ අපි දන්න ඒ කියන්නේ curve එක උඩ ඉන්න point එකක් දන්නවා පුතේ ඔයා දැන්. Exactly you know a coordinate which is on the curve. ඉතින් එතකොට එයා equation එක satisfy කරන්න. එතකොට පුළුවන් මේ x value එක substitute කරන්න, y ට මෙයාව substitute කරන්න. So we can find unknown terms using that method, right? I hope you can understand. Right. Complete that. So next week's paper, right? Next week's your exam paper, you will get a full question from this. Okay. Right. Now we found the horizontal asymptote. We will need that when you draw the sketch the graph. So no need to find it again. We already found horizontal asymptote is equal to 1. This one I will erase. Now we can write. We found that p is equal to 2. Now we can write p equals to 2. And they ask us to find f dash x. They have given f dash x as minus 3x plus 5 over x minus 1 to the power 3. They have given us f dash x. Okay, so find f dash x. How to find f dash x? Horizontal asymptote is equal to 1. We will write it later again, right? F dash x, see? denominator squared, so to the power 4. Clear? Denominator into differentiate this, x minus 1 squared into differentiate this one, what we get? 2x plus 1. Clear? And then this thing, x squared plus x plus 2 into differentiate this one, we will get 2x, sorry, 2x minus 2 කියලා එනවා. නැත්නම් පුතාලට මෙහෙම ලියන්න පුළුවන්. මෙයාව differentiate කරාම 2 into x minus 1 නේ. Right? 2 into x minus 1. Okay. 2x minus 2, we will need to take 2 out. It is x minus 1. Or else we can think it as x squared term and then 2x minus 1 and x minus 1 once you differentiate 1. Like that also we can find. So however we get this. Can you see in each term we have x minus 1. Right? Before simplifying this, මෙයාව දැන් මෙහෙම expand කරගන්න කලින් ඔයා බලන්න denominator එකත් එක්ක කැපිලා යන terms තියනවාද කියලා. And also as they have given you the answer, you can target your answer. No? Clear? In the answer it is to the power 3. One of these get cancelled, x minus 1 term, x minus 1 term, and here it become 3. Okay, now what we have? X minus 1 into 2x plus 1. And minus 2x squared minus 2x minus 4 over x minus 1 to the power 3 plus 2x squared minus 2x plus 6 minus 6 and minus 1 minus 1. Okay, minus 2x squared minus 2x minus 4 over x minus 1 to the power 3. So these things we have to solve soon. Then we get minus 3x minus 5 over x minus 1 to the power 3. So that's how they have given us the answer, taking minus out 3x plus 5 over x minus 1 to the power 3. So that is actually solving. After writing this line, you have to solve correctly and get the answer. Rest also can understand that step, finding f dash x. Okay, you just write down this step and then the final answer and leave some space to write these things. Soon we will move to the graph because I want to finish this question. Last one we won't be able to do. Not enough time, right? So I want to finish this one. So I will do this question for you, right? You then repeat the question again at home. Let's do like that. Okay, so however, repeat all 3 questions that we discussed before the class, before Saturday class, others also before next paper, right? Okay. So once we solve, okay, now we will continue. Let's move the question. Look at this for the hence find the intervals on which fx is increasing and intervals on which fx is decreasing. Also find the coordinates of the turning points of the graph. Then it is given, okay, then they have given us f double dash x is this, showed that point of inflection is at this point, and then we have to sketch the graph at last, indicating turning points, asymptotes, and point of inflection all. Okay, so very nice question, right? Now also observe that this question is structured. Even though a student is unable to do the first part, they can continue because see they have given the value of p here. Clear? Then p දීලා තියෙනවානේ. එතකොට කවුරු හරි ළමයිට මුල් ටික අපි හිතමුකෝ තේරෙන්නේ නැතුව ඉදියා කියලා exam එක වෙලාවෙ තිබෙයි. එතන තේරෙන්නේ නැති වෙන දෙයක් නැහැ. Right? I'm telling if someone is confused with the first part, still you can continue the whole rest of the, you can continue the rest of the question. That is the way that they have structured the question. Clear? Right. Okay, now so they have given us f dash x is equal to, we found that f dash x equals to 3x plus 5 over x minus 1 to the power 3. Okay, we have to find the increasing and decreasing intervals, and then we have to find the turning point, and then they have given us f double dash x means what? We have to find the point of inflection. Okay, look at this, all of you. Number and teacher another no. Right, see, vertical asymptote. Vertical asymptote. When we get the vertical asymptote, yes, at the point where this function is undefined, that is at x equals to plus 1. Clear? Denominator 0 වෙන වෙලාව main function එකේ. ඊට පස්සේ at stationary points, f dash x is equal to 0. At stationary points, f dash x is equal to 0. F dash x is a fraction. This fraction is equal to 0 when its numerator is equal to 0. So that is when x equals to minus 5 over 3. මෙයා 0 වෙන්නේ පුතේ when x equals to minus 5 over 3. Clear? Therefore, we have one vertical asymptote, one stationary point. So we will mark them on the number line now. Minus 5 over 3 and 1. Clear? Minus 5 over 3 and 1. So minus 5 over 3 means like what? 1.6 minus, yes, 1.6 something, right? 20, yes. Okay. So we are observing, see, we are observing the sign of f dash x. Sign of f dash x. Then draw this one. Then බලන්න මේ minus sign එකට මම bracket එකක් දාගන්නවා. මොකද because it can change the sign. as sign එක change කරනවානේ මේ ලියන minus එකට bracket එකක් දාගන්න. Okay? And the denominator also you have to the power 3 this time. Therefore, you will be careful. Right? Write the ranges minus infinity to minus 5 over 3, minus 5 over 3 to 1, 1 to infinity. You have to mention these things. Okay? You have definitely mention these things. Right. So we have like this. Clear? This is always negative, minus, minus, minus. Okay. Now you substitute a value which is less than minus 5 over 3. Here we have, let's say, minus 10. 3 times minus 10 plus 5. Easily we can recognize that it is negative. Minus 10 minus 1. Minus answer to the power 3 also negative. Odd power so the negative. Even not the positive. Right. Here to here we have 0. Substitute 0. 3 times 0 plus 5 positive. 0 minus 1 negative to the power 3 also negative. Number greater than 1 please. 1 to whatever you can 3. 3 times 3, 9 plus 5 positive. 3 minus 1 positive to the power 3 also positive, like this we can get. Now think about the sign. Minus into minus plus. Plus over minus minus. Minus into plus minus over minus get cancelled and we get plus. Here also we will get minus. Minus into plus minus over plus means minus. Clear? Now how we get the gradients? And come the tangents this way. Gradient is negative. F dash x means gradient of the tangent. Negative. So the tangent slides this way. Positive tangent slides this way. Negative tangent slides this way. Is it clear? Right. So increasing or decreasing. If sign of f dash x is negative for a particular range means this is decreasing. And here it is increasing. This is decreasing. Okay. So we have the special point, what? Stationary point minus 5 over 3. Clear? So we can say decreasing, increasing. So what is it? Yes. Minimum point. Local minimum. Okay, here we have the local minimum. At what? X equals to minus 5 over 3. At x equals to minus 5 over 3. So, now you can calculate the y value. How to calculate? May I substitute? X equals minus 5 over 3, substitute there. Okay, see. X equals minus 5 over 3. We are going to find the y value. May I substitute? Minus 5 over 3 squared means what? 25 over 9. Minus 5 over 3 plus 2. Right? Then minus 5 over 3 minus 1. Minus 8 over 3 squared. Minus 5 over 3 minus 1 minus 8 over 3. All things squared. That's how we get. Then denominator is denominator is 64 over 9, right? And here also we can get the common denominator. So we will get 25 minus 15 plus 18. So 9 they get cancelled out, right? 3 28 over 64. You can divide both the denominator and numerator by 4. So we'll get 7 here and we'll get 16 here. Okay, correct answers. I mean, those who tried it. I think I didn't give you time, no? Yes, nobody tried it. Someone got, yes, Hana, Savija, very good. You have tried it, Yashasvi. Okay, so likewise we can find the what? Local minimum, local minimum. Others listen well and then you can repeat it at home again, right? So teacher will then because it will take time if I give more. Okay, because I have to discuss this question now. That's why. Right, so we get like this local minimum is this minus 5 over 3 comma 7 over 16. Okay. Right. Then okay, we did that part. We found the turning points. And then also now we know the vertical asymptote. Now we know the turning point, and horizontal asymptote we already found. No need to find it again. Horizontal asymptote. I will just write down because we need then to sketch the graph. Y equals to 1. Y equals to 1, yes. Y equals to 1. And then about the second derivative. Look at this, all of you. F double dash x is given as 6 into x plus 3 over x minus 1 to the power 4. Now, what do you mean by f double dash x? Once you differentiate f dash x, you will get f double dash x. Clear? Once you differentiate this once, you will get this. Clear? Now, they have given us, no need to find it, they have given us. Right? Point of inflection, they are asking us to find the point of inflection. So, at point of inflection, f double dash x is equal to 0. Now, you can say, this is familiar to you. At stationary points, f dash x is equal to 0. At point of inflection, f double dash x is equal to 0. F double dash x is a fraction. This fraction is equal to 0 when its numerator is equal to 0. So, we can write that is when x equals to what? X equals to minus 3. X equals to minus 3. Clear? Then, so at point of inflection, f double dash x equals to 0. So, that is when x equals to minus 3. Now, what we have to do? Yes, now you draw a chart. Now, you have to confirm whether this is the point of inflection, and you have to observe whether how it behaves concave up, concave down, for the intervals. So, you can draw a number line and mark the vertical asymptote also we usually mark here. Then it is easy for us to sketch the graph, and also this one, point of inflection. Clear? So, minus 3 and plus 1 I will mark here. Clear? And we have to observe this time not sign of f dash x. Here we observe sign of f double dash x. Sketch it. 6 is positive. X plus 3 to x plus 3 ගැන විතරක් කතා කරා නම් ඇති ළමයි. Why? Denominator is also already positive, whatever the value, to the power 4 can even power. Clear? So here to here we have minus infinity to minus 3 values and minus 3 to plus 1 values and 1 to infinity values with it. Hi, extra numerator in bracket to the bracket that you have here x plus 3 bracket, you substitute that to that one only. That's enough. Tell me a value which is less than minus 3. Minus 3, less than minus 3. Minus 4. Substitute minus 4. Minus 4 plus 1, negative ones. For values which are greater than this, 0, 0 plus 3 positive. This one definitely positive. Can you understand? Sign of f dash double dash x is negative means this curve is concave down, concave up, concave up. Okay, so you write in words also, concave down, concave up, concave up. Okay, so then now we can see, now this is the point of inflection, right? This is, we have to talk about this actually. On the either side of the point of inflection, what has happened? Concave down, concave up. Clear? Now, therefore, right, point of inflection is right. You can find the coordinate also. X equals to minus 1 over 3 is the point of inflection. Now we can see it. We can find the y coordinate as well. So find the y value. How? Okay, we have to plot it now. Substitute it here, right? So substitute minus 3. Y equals to, right? When x equals to minus 3, at x equals minus 3, y equals to what? Minus 3 squared 9, minus 3 plus 2 over. So I am substituting it here. मैं यार substitute कराने. 9 minus 3 plus 2 minus 3 minus 1 means minus 4 squared. That is 16. Right. So here it is 6 plus 2 8. 8 over 16 means 1 over 2. Clear? Therefore, we can write therefore at minus 3 comma 1 over 2 is the point of inflection. Confirm definitely you have to confirm these things, right? Minus 3 comma 1 over 2 is the point of inflection. Race has also can understand the thing up to this one. Now in the today's paper, this is the first time we found this f double dash x thing, yes, right? So keep in your mind, f double dash x is equal to 0 at point of inflection. Then you draw the chart, similar chart, right, mark in this one and include the vertical asymptote also, that will help you when you are sketching the graph. Then you observe the sign of f double dash x this time. Clear? And then to find the coordinate, we know the x coordinate already, x equals minus 1 or minus 3, and then substitute in the main function to get the y coordinate of the point of inflection. Okay? Yes, definitely we have to do. Okay, we are getting marks for this, right? It is not enough to find this one only. Definitely you have to draw this one and confirm that it comes concave up, concave down, and that is the feature of point of inflection. You have to definitely mention these things. Is it clear? When it is point of inflection and they will just tell you to find the point of inflection, still you have to draw this and confirm it that it is a point of inflection. Okay, Hannah? Because you are getting marks for those parts. Right, now I will sketch the curve, right? I will sketch the curve here. I hope to sketch it here, but I will think that this space enough. Let's say we manage to make it. because then you have the whole thing to write now. Vertical asymptote x equals 1. Vertical asymptote x equals to 1. Horizontal asymptotes y equals to 1. Okay, and then you have the local minimum. See, we found that local minimum is minus 5 over 3 comma 7 over 16. Okay, minus 5 over 3 comma, see, this is 0 point something. So minus 5 over 3, this side minus 1. So this is minus 1, this is minus 2. So minus 5 over 3 should lie somewhere here, minus 5 over 3, right. See here. So these are rough sketches now, but yeah. Then local minimum we have 7 over 16, 0 point something, 0 point. So I will mark it 7 over 16 here. Here we have the minimum point. Okay, here we have the minimum point. Then we have a point of inflection at minus 3, 1 over 2. Minus 3 and half. Yes, Lamai, I will just sketch one little bit, because we had to mark half also. Y equals half, point of inflection. Say this is half, this be 1. Okay, right. So this is half, this is 1. Half, minus 3, you have the point of inflection. Minus 2, let's say, minus 3. This is the point of inflection. Make it a horizontal asymptote. This is the horizontal asymptote. Clear? And minus 5 over 3, 7 over 16. 7 over 16. So 7 over 16 is here. So here we have the minimum point. Like this. Here we have the point of inflection. Is it clear? The way to mark? Right. Value roughly or 7 over 16, you just divide 7 by 16 and then you can have a rough idea about the value and then you can sketch. Right. Okay, let's do. Right. See, now we have this. The point of inflection is turn. Concave, see, concave up and then concave down when it goes to infinity. So that should happen there. See, concave up and now you have to turn it. Concave down, then concave down. So change otherwise you don't even marks, right? Change like this. You have to do that change. And then values tends to, it goes along the horizontal asymptote. Clear? It goes along the horizontal asymptote. I mean, goes along means it get closer to the value 1. It never, that's 1 minute right. And then this one, we don't have to find the intersections. No, intercepts like it's okay, right? Then you can just go the minute in. You know that this happens. This intersects at minus 1 over 3. Sorry. At the beginning, they have given us the graph intersects at minus 1 over 3. The graph intersects the horizontal asymptote at minus 1 over 3. So, this is a graph, and it goes to infinity. Raise hands also can understand that thing that I told you now. Because in the question, right, they have given that at x equals to minus 1 over 3. X equals minus 1 over 3. The graph cuts the horizontal asymptote. That's why point cross. At the beginning, they tell that the graph cuts the horizontal asymptote at x equals to minus 1 over 3. Clear? Clear? And then this side what happens? It should be either this curve or this curve. So from this way, very easily, 1 to infinity, it is a concave up one. So what is the curve? Concave up one. This is the curve, not this. Is it clear? That is the way to sketch the graph of that. Okay, so this is the whole question. Right, you can note down the things, right? You can note down the things. Raise hands also can understand well. Now there are only 16 students, right? දැන් හොඳම ගාන හදනකොට ඉන්දිය නෑ කට්ටිය නේ. Minuri, can you understand, Minuri? Did you watch the recordings before the session? Okay, students, so that's about this. So I will just send a photo of this one and you can note down. Right, I hope you can understand. So we discussed the recent two past papers, 24 and 25 and also 21. Right? Okay, goodbye, Lama. Good night.